So.
Maud, who are you guys missing? No, you're in the wrong spot. You're supposed to be over here. Isaac, who are you guys missing? Ciela. Do you remember? Alistair, who are you guys missing?
Same person with yesterday.
Thanks.
Oh, Thomas.
Okay, so again, lightning fast trade today. One thing that you should have from yesterday, how to convert from degrees to radians. Another thing we're gonna do today, reference angles. And coterminal angles. Okay. 60 minutes in an hour. How many hours is 36 minutes? Well, I'm gonna do the conversion, like, I'm gonna make the units cancel out. 1 hour is 60 minutes, thank you. And then reducing 36 over 60, take a 6 out of the top and bottom, 6/10, which is 3/5 of an hour. Okay. So, to convert from radians to degrees, it's easier to do half a circle than a whole circle. Emma, how many degrees are in a half a circle? 180. And Nava, how many radians is in half a circle? Pi. Rihanna, how big is the number pi? As a decimal. 3.14 or something or other. Okay, Emmanuel, double that, like 2 pi is a full circle, 360 is a full circle. She just said pi is about 3.14, so what does that double? What is 2 times pi as a number? 6 point something, right? 6.28. So, here I'm gonna show you again my circle. There's 1, 2, 3, 4, 5, 6, and a little bit, about 0.28, blah, blah, blah. These are radians. Does anyone remind me what a radian is? Emilio, do you remember? Alistair?
Is it the same length as the radius of a
It's always in the same angle.
So, this is a radian. This is a radian. So, if you take the radius off and rip it around the outside of the circle, it's how much the angle sweeps out. So, these all visually look different sizes because the lengths are all different, because the radiuses are all different. However, if, as Emery just said, if you look at the angle that got swept out is the same. That angle is 1 radian.
So the radian is an angle.
A radian is an angle measurement. So this angle is about 52 degrees. It is 1 radian. Straight up. Okay. So to convert, I did my minutes to hours by doing this conversion. Now what do I set up to convert these degrees to radians?
Pi over 180.
Pi radians over 180 degrees. The units match up. And as a reduced fraction, what'd you guys get?
7/4. 1.6 or 7.5.
Thank you. What when working with radians, guys, the thing that is pretty common when you do multiple choice or fill in the blank answers, you drop the pi.
I have it written.
I know, okay, so you just
Yeah.
set it 7/4. I'm like, don't forget the pi. Marty, how do I, convert this one? 5 pi over 6, how do I turn that into degrees?
Multiply it by, oh wait, 5 pi over 6, 180 over 5. Okay.
So this was radians. So 180 degrees over pi radians. Radians cancels, pi's cancel. 5/6 of 180. 180 divided by 6 is 3. 3 times 5, or 30 times 5. Okay, Danny? 4 pi over 3. How am I gonna convert that?
Well, want to do the same thing, put it on the top, 180 degrees.
Okay?
And then, yeah.
Pi radians, 180 divided by 3 again is still 60. 60 times 4 is 240. Is there any confusion about converting from radians to degrees or degrees to radians? We need to remember the conversion factor. Half a circle, you did a full 180 going from here to there. Half a circle, you went pi. Big and plus?
I'm a bit confused. I went from degrees to.
Okay?
Oh.
Do you agree with half a circle is half a circle? Okay. This has degrees on the top, so I want degrees on the bottom. How many degrees in half a circle? How many radians in a half circle? Okay, degrees cancels, that 10 cancels.
And you always assume it's gonna be half.
That conversion rate's easier. You could say a full circle is 360 degrees, a full circle is 2 pi radians, but you're gonna divide by that too. So you might well, so it's not assuming, it's true, 180 degrees is pi radians. 10 pennies is a dime. 4 quarters is $1. Conversion rates. Okay, so retakes are tomorrow and Monday. You should have filled out the form already, and quiz corrections are due tomorrow, yeah?
Can no one look at our grade for the district assessment?
The scale came out, well, I finally found the scale this morning, so like third period, but I teach third period, so I haven't put them in yet. I will put your district assessment grades in at lunch, and, most of you were blue. Blue is the good color. Then green. There were very few yellows, and I don't think there were any reds. Yeah.
It goes blue, green, yellow, red.
Yeah, and there's another color. But yeah, they count.
What's the curve looking like?
I haven't gotten to see the file. Someone sent me the link.
Oh, okay.
So I haven't seen it.
Praying for it.
Yeah, and if you have the other side of the letter that you want, like if you have a 71, don't do a retake. Because that's not gonna change you in a manner that you would like. If you have a 79 point something, okay, maybe. Then you wanna do a retake. But if you have like a 71, an 81, and actually an 84, I don't think that's gonna change. Y'all. Okay, we talked about this yesterday, standard position. The starting point, the starting side, this is 0, either 0 degrees or 0 radians. The positive angles go counterclockwise, and then the ending side of the angle, we call that the terminal side. It's where it stops. Buses stop at terminals, trains stop at terminals. It's the stopping point. This one they're saying, hey, look, this is the picture of 130 degrees. And Isaac, we haven't discussed it in here this year, or at least not recently. What are the names of the quadrants? Like, what is this one? 1? Where did the angle land? 2. Quadrant 2? What is this one? 3. So this one? 4. Okay. So counterclockwise, 1, 2, 3, 4. Cool. All right, we're gonna do a couple of things here. Want to practice drawing them in standard position. So 40 degrees, starting here, going in the positive direction. Does it go past that stick at the top, or no? Do I draw it more than this, less than this, or about there? About that? Okay, I agree. That's 40 degrees. There it is, drawn in standard position. Cool. Then there's a thing called reference angle. Sorry, Alistair, what's the question? Yeah, you should draw this. There's something called a reference angle. And this one is going to sound stupid. The reference angle is if you went back to ground level, what angle is it? Well, and reference angles are always positive. Reference angle there is 40. All right, so what? $90 degrees. I believe you all know this one. There's 90 degrees. Getting back to ground level. Again, the reference angle, not super interesting. Not yet. Still not interesting. Pi. Danny, how do I draw pi?
Just like 180.
Just the 180. So last period I had students come up here and draw them, and every single one that had to be drawn as a radian, they wrote down degrees. Don't write down degrees. It starts in radians, stay in radians, unless I ask you to convert. This one also not interesting. The reference angle, it is ground level. We're done. We're there. Okay, pi over 3. Monte, what quadrant is pi over 3 going to land in? 1, 2, 3, or 4? 1. Okay. Conchetta, how am I going to draw pi over 3? Don't know. Okay. How much in radians? How much is that? Pi. 1 pi. So I'm going to write it as 3 over 3 pi. How am I going to draw 1/3 of that? It's gonna, Monte said it's gonna land in quadrant 1.
60 degrees.
So it's about 60 degrees, it's exactly 60 degrees, but guys, radians makes more sense. Cut it into thirds, chop, chop. 1, 2, 3 pieces. Here is your pi over 3. Radians rocks, it really does. Emilio, you will learn to see the light, you will love it. Eventually. Yeah. Okay, reference angle, to get back to ground level, the reference angle is pi over 3. Different, weird, because they have, which way do angles go when it's negative? Is it, so do I go this, do I go this way or that way for negative 1? Down, okay. Alex, negative pi over 6, is it gonna cross the first stick, the second stick? It's gonna go this far? but not the, and I was like, no, so what does it do?
What's that? Right.
Is it big angle, is it baby angle, is it a medium angle?
It's a small angle. It doesn't go past the first one.
Okay, so, as we did here, that's cut into thirds. 3, 6, 4, 5, 6, 6. Alex says, it doesn't go that far, it's a baby angle, there's negative pi over 6. Alright, first one where there's, the reference angle's different. Anyone got a guess what the reference angle's gonna be?
30.
Okay, keep it in radians. Positive pi over 6, yes. Alright, why is this useful? The other day I asked you guys to remember this triangle, and it's 30, 60, 90. I'm gonna write it with radians. Pi over 6, across from pi over 3 is root 3, and then there's 1, 2. Cosine of pi over 6. Cosine is adjacent over opposite, so cosine of pi over 6 is root 3 over 2. Supposedly, you guys know your unit circle already. Do I believe that? No, my calculus kids do not know their unit circle. So, I want to get you used to how we're going to do this. This triangle, reference angle is pi over 6, so cosine of pi over 6, negative pi over 6, is also root 3 over 2. It might be negative, or it might be positive, but it's going to be root 3 over 2. Is cosine the x direction or the y direction? Just a second. It's the x direction. So is the x direction positive? So cosine of negative pi over 6 is also root 3 over 2. Alistair, what's your question?
You have the right, I didn't see the plus minus, sorry.
Getting there, or we were finishing. Okay, here's the question. Sine of pi over 6, looking at the triangle. Abraham, sine of pi over 6, sine is opposite over hypotenuse. So what is sine of pi over 6?
Opposite over hypotenuse.
In numbers, using the numbers that are on here.
Is square root of 3 over 2.
Nope, opposite pi over 6, opposite is 1.
1 over 2.
Okay, so sine of pi over 6 is 1 over 2.
Just 1/2.
Yep. Here's the tricky question. Sine of pi over 6, reference angle is pi over 6. It's going to be 1/2. It might be negative, it might be positive. Which one is it going to be? Why?
Because going down
Because the y value is going down. This is why we want to know what reference angles are, because if you know these guys, if the reference angle is pi over 6, you know sine of that, whatever angle it is going to be 1/2. It might be negative, but you know it's going to be 1/2. Okay. Trying a couple more. And actually, I would like you guys to come up and draw the angles on here. So, Rakib, can you draw 100 degrees? No? Maud, can you draw 100 degrees? Alistair, can you draw negative 100 degrees? Emery, can you do the third one, negative 7 pi over 6?
Yeah, I can.
Can you put it in the rating?
Oh, sorry.
That's dead.
Fernando, can you do the 300 degrees? Mache, can you do the 2 pi over 3? Sorry, it's hard for you to get out of there. Don't convert to degrees and then go. Is that what you're doing?
Chance. I shouldn't do it real.
Ooh, thank you. He's writing reference angle down too. So, okay. All right. Here we go. 100 degrees plus a smidgen more. I would make it a little bit smaller, but we're good. What is the reference angle going to be? Reference angle is going back to ground level. What is this angle? So it's not 100. Oh, 80. How'd you get the 80?
Because 100 plus 80 is 180.
The reference angle is the littler guy. It's got to be less than 90. This one, negative 100 degrees, what's the reference angle? It's always positive. 80. How many degrees did we have to go to get back to ground level? Reference angle here is also 80, and there is 80. All right, this one, not to out the person who did it, to degrees and then drew it out. Radians is so much better. So I know it's in the negative direction, so I know we're going that way. Is 7 over 6 more than 1 or less than 1? More than 1. It's 6 pi over 6. It's this. How much more is dripping over? 1/6 pi. So draw your full pi, and then how much more? 1/6.
That's right.
What's the reference angle? Pi over 6. Radians rocks. Whatever that denominator is, reference angles, pi over 6. Reference angle, pi over 3.
So for 300 it would be 6.
Okay?
I mean, it was
this-
still right there, right?
You drew it correctly, yes. And just trying to save you time.
Okay.
Like,
Yeah.
and eventually, like, I'm really gonna work hard at breaking you guys of the habit of, okay, it's this many radians, don't know what that is, I'm gonna make it degrees, work on it in degrees, and then put it back in radians. You're just gonna, you might make an arithmetic mistake in there and just get screwed and take too much time.
Is the reference angle for the second one 260?
Okay, reference angles are always 0 to 90.
Oh.
Small exception if we get all the way to 180. Okay, this guy, 300 degrees, reference angle is the small angle getting us back to ground level. What is that? 60 degrees. Positive 60 degrees. Reference angle is always positive. And why this is useful. Again, 30, 60, 1, 2, almost 3. Said cosine of 300. I have no clue. Reference angle for that, you guys just told me, is 60. Cosine of 60, 1/2. Okay, cosine of 300 is also going to be 1/2. Might be negative, I need to check. Is it going to be positive or negative?
Which one the cosine?
On the cosine of 300,
It's gonna be positive.
because
Yeah.
the x is positive. So do I have the ones memorized for cosine of 240, cosine of 310, cosine of 315? No. I know cosine 45, I know cosine 60. Yeah.
On the test, do we have to know if it's positive or
Not yet? All right, 2 pi over 3, I agree with how it's drawn. No, what's the reference angle?
Left.
How much angle angle is left to come back to ground level? Okay, it was easy when it was degrees, 360 minus 300. How many things is half a circle? Pi. So a whole pi, take away this much pi, what's left?
What?
1/3. And as I said, guys, reference angle, pi over 6. Reference angle is going to be pi over 3. If it's reduced, that's what it is. Yeah. Why is it not? Oh, it's not. Sorry, that was supposed to be an equal sign. It's not negative. It's always positive. My bad. Yeah.
I'm really confused. For the reference angle, pi over 6, why isn't the reference angle
The
the angle to get back to 0?
angle to get back to the x-axis.
Okay.
Back to ground level goes to the x-axis. I used to say it's where gravity goes, but gravity doesn't drag you up. So it's getting back to ground level. If you're below, come back up. Gravity doesn't suck you sideways. Yeah?
How did you do the reference angle for the third?
For this one? Okay, reference angle is how much do we need to go back to ground level? Well, when Emery drew it, he drew a full pi, and then he had to draw that little teeny bit more. That teeny bit more is the reference angle. How much past 180 did you go? Okay. So, that's reference angles. Then I need to tell you about quadrangle angles. It hit the axes. Oops. So when it hits the plus sign, 0 degrees, 90 degrees, 180 degrees, 270. What is that in radians? Well, that's 0. What is 90 in radians? Pi over 2. What is 180 in radians? Pi. 270 in radians? Thank you. And I don't know, just for grins and giggles, going backwards, negative 90, negative 180, negative 270. So negative pi over 2, negative pi, negative 3 pi over 2. So with the idea of reference angles, and those two triangles, how do I label this one, Cherry? What's this angle up here?
That's the adjacent.
Is it 30, 45, 60, what is it?
30.
30, it's the smaller one. So what's this one?
60.
60. Okay, who remembers Valentina, do you remember how to label the triangle?
It's the hypotenuse 2.
It is.
And the short one, square root, 1, and square root 3.
Maud, do you remember this one? What is it? Okay, so knowing those two triangles and this. You guys now know the entire unit circle with the idea of reference angles. So X, Y, 1, theta. Sine, Emmanuel, sine is opposite adjacent hypotenuse, whatever what? Sine of theta is opposite over hypotenuse, sine of theta is the y. Okay? So, sine of 30, I'm gonna look here. What is sine of 30? Brianna, what is sine of 30? Look at the triangle.
2/1.
Sine is opposite over hypotenuse 1/2. Okay, Jack, you ready? Here's 150 degrees. What's my reference angle?
30.
30. Okay. So sine of 150, what's sine of 150? It's gonna be the same thing as sine of 30. And now we gotta check, sine the x value or the y value? Y value. Is the y value here positive or negative?
Positive.
Positive. So sine of 150 is also 1/2. Hold on. Sine of 210, all right? What's your question?
I was gonna ask, how do you know that the reference angle for 150 is 30?
Because 180 degrees cut off that 150, what little drip is left? Like how many degrees did you have to go to finish the half a circle?
Okay, and also, what if it's not a number like in between those?
Okay, that's a different problem. On the unit circle, it has to be one of these. It has to be clicks of 30, 45, and 60, and, yeah. Okay, sine of 210. 210 takes me here. What's the reference angle? Trey, what's the reference angle if this is 210?
30.
30. So sine of 210 is gonna be 1/2. Is it gonna be positive or negative?
Negative.
Negative, because the y value is negative. So reference angles, knowing these two triangles and reference angles, get you the whole unit circle. All right, why is this stuff helpful? Well, if something lands on the quadrants, yeah.
Wait, so like that's always gonna be the same as the reference triangle or whatever, cause like how do you know that
Okay.
1/2 is?
'Cause
Since the angle's 30, you can
Since the
use sine
reference
on the
angle is
reference
30,
angle.
keep trying to change the color, it's not happening. Since this reference angle is 30,
Yeah.
the proportions of the opposite to the
Okay, yeah.
hypotenuse are still gonna stay the same. This one, the y value was negative, all right, it's negative 1/2.
Okay. And so since we're going like clockwise 30 degrees, it would be -1.
I see it more as this is below the x-axis, so the y value is gonna be negative.
Okay.
But whatever works for you. Okay. And remember we said this, x, y, cosine, sine, alphabetical order. So, looking at this, yes.
How do you know which triangle it is?
When you find your reference angle, and you got 45 degrees, you would look at this one.
What if I got?
If you got something weird, like Fernando was just saying, what if you get like 27? That's not on the unit circle, I can't
Oh,
ask you
alright.
that.
Okay.
So it'll only be degrees of 45, 60, or 30?
It'll be 30, 60, 90, sorry, 30, 45, 60, or some multiple of those.
Okay.
90, 120, 210, 315, yeah.
So it'll be like what was on the delta math of like pi over 12.
I'm not guaranteeing you that. That second quarter, or third quarter, and there's it's done in honors, and it's a pain in the ass. The way you get sine of pi over 12,
30 and
you do sine of 45 minus sine of 30, well, you do this, which expands to something else, which again is third quarter. We'll get there. I'm hoping the answer is no, but I'm not, I haven't checked lately if they've taken it out of the curriculum. Isaac, 90, 180, 270, pick one of them. 180. Okay, sine of 180. So Jack, here's a question. Am I gonna, what's the reference angle of 180? 0. So is that in one of these triangles? No. So I'm gonna look at this guy, and I'm gonna face 180. Here at x, y, cosine, sine. Which one, sine is the x value or the y value? So what is the y value when I'm facing 180? So sine of 180? 0. Supposedly you guys all know unit circle already. I hate the way they do unit circle. It's in algebra 2. Y'all did it. Cosine 180. Still facing the same direction. Jack is cosine the x value or the y value?
Yes.
So what's the x value facing that way? Clicking a little, Alistair? There's one purpose I gave. Just a little. I know, it takes a minute or like 4 days. But this is, so reference angles help you figure out which of these things to use. So Jack, if it's not on, you got your reference angle, it was 23. I don't know what that is.
If I like get 23 on a test, that means like I did it wrong.
You probably did the arithmetic wrong, or we're leave it calculator ready. If I said, what is, sine of 203, you're like, okay, reference angle's 23. Well, it's gonna be sine of 23, negative sine of 23, because it's gonna be, choose a good number again, sorry, but
Wait, why?
calculator ready.
Why sine? Why not reference angle 23? Why sine?
I was just trying to come up with, he's like, why in the world, like, what if I get a 23 and I need to do the trig value of that? And he said, if I got that, doesn't that mean I probably made a mistake in arithmetic? Probably. However, we've done things without calculators, and we told you leave it calculator ready. And I was trying to come up with a question that would make me leave it calculator ready, and I did it poorly. Go me. Yay. Gotten it out. Okay. One other thing we need to do. Coterminal. You guys ever play board games where you spin? No? No, you never played with a spinner?
We have lunch.
Life, right? The numbers 1 to 12. So, Abraham's playing the game and he's
Is
like,
that gonna be my thing now?
he wants just that little bit, he wants it right there, so he just goes, eat. And then your little brother's like, no, you have to do it all the way around. And then have it land there. So it goes, resets, and Abraham says, fine, little brother. I will spin it all the way around, and it still lands there. How many degrees did it sweep out to land exactly in the same place? 370. How did you get that? So this is coterminal. He spun it all the way around and landed in the same spot. Okay. Now his other brother, because you got two, three. Okay. They're like, you gotta spin it the other direction. Okay. So goes back to reset, and he spins it there, and it lands exactly in the same place again because he was the luckiest person ever. How big is the green angle?
352. Gonna be negative 370.
Negative.
Can we interview someone really quick for your web?
Okay. Emma?
It's Kira Trevor.
Okay, so coterminal, what he did here, he spun backwards. And you guys said 350, and then it's like, we've gotta remember it's backwards. So negative 350, how do we get that? We took the angle and we subtracted 360. Why is this useful? Well, so Jack, here's one, if I said, what's sine of negative 350? It's not on the unit circle, but if I gave you a multiple choice, what is it equal to? It's gonna be equal to sine of 10. So if there's an example of, it's not on the unit circle, but I might say, well, I don't know its exact value, but what value will it be the same as? And it will also be the sine of 370. So coterminal angles Add a full circle, subtract a full circle. Let me show you what you guys have as homework. So sorry. It's not hard.
Yeah, but I'd rather review from anything.
That was yesterday.
That's today.
That was your free time, was yesterday. That was yesterday's homework. Guys, take a sheet in the back. And then did they ever find you and try to track you down, like supposedly yesterday and the day before, and like, you never walked into my classroom? Zero. Are there any extras out there? And Isaac, did you get one?
Yo.
What are we looking at?
Can you drive? Actually, never mind. Do you do something,
Yes,
like
right,
little
yes,
things?
I know, yes, yes. We have my job, too.
No,
Yeah,
Don't
I was
even
making
give out
sure
my
that was
location.
you. That I saw.
No work.
Is it like a normal?
But I don't like it, I
No.
was miserable.
Okay, guys.
I was very bad at working.
No. So, someone just asked, so we still have a quiz next week, like a big one, like 20 points? No. We're gonna have something next week though on however far we get through this trig stuff, so guys, get off the phones. So I can ask you degree radian conversion. I can ask you reference angles. I can ask you coterminal angles. I can ask you to draw it from standard position. So right here, which this is on your worksheet, draw the 50 degrees. Okay, there's 50 degrees. What quadrant does it land in? Lands in quadrant 1. State 2 coterminal angles, one positive, one negative, okay? So to find a coterminal angle, that angle a positive, add 360.
Do we have to draw it or just tell you?
Well, on your worksheet, guys, the worksheet is draw it, name it, find 2 angles. Here's a positive coterminal angle.
Do we have to
and-
draw the coterminal angles?
No.
Okay, you just have to find them.
What's the reference angle for this one?
50.
50, it's uninteresting.
Oh.
230, what quadrant does it land in?
Three.
Quadrant 3. So I went 0 to 90 to 180 and then stopped short. So a coterminal angle, add 360, so a positive one
590.
and a negative one.
So you just.
Negative 1.
So there's a positive coterminal angle and a negative coterminal angle.
So wait, you always just add 360 in.
Okay, careful, guys, shush. To find a coterminal angle, add or subtract, Trey, a full circle. The first two, just a second, we're in degrees, so add or subtract 360. This is radians, don't give me degrees. I want it in radians. Full circle in radians is 2 pi. I'm gonna do common denominator. And I'm gonna add and subtract the full circle in radians. So one coterminal angle is 5 pi over 2. The negative one, negative 3 pi over 2. Emery, what?
Oh, will we be able to have a calculator on this?
Maybe the stupid crappy one, yeah?
Sure.
Guys, what's the reference angle on the second one, part B here? 17. It is not 17. 230 minus 180, 50.
Not bad, buddy. What?
Ciao.
I just. 2 times.
Let's lock in. Let's lock in, bro.
Yep.
That looks dumb.
It does, but it's not the one.
Like, what's different? What makes it different?
If it's a radius, would you?
Emma, I don't know why he's coming. Who only knows you're in this period?
Oh, yeah.
Are you receiving? No, I'm just, oh, I was just searching for Oh, okay. Yeah, I gotta go get my Chromebook back. Okay, I can get it. I'll be there.
Talk about how, Daniel Benoit, not one of us, he wasn't born American. Yes, you have a Chromebook. I do. Okay, that's what you need. So get the Chromebook out.
They're like, what makes it different than every other team? And I was like, I don't know.
Thanks for coming in, I totally forgot.
They're just like awkward and everything. Oh, I actually want to die.